Hi, I am Batuhan Tekmen, a second-year computer engineering student here in Middle East Technical University. And today, imagine you are an archaeologist and found a completely destroyed building, and what you have in your hands is just the bricks of this building, and you want maybe to record this building, and you want to predict this complete 3D shape, this building's 3D shape, with just 1 millimeter error precision. This is what achieved by the AlphaFold2 in last month, and today I am going to talk about two benefits of AlphaFold2 in science. Actually, this was a 50 years old dream to predict protein from its first conformation. In 1916, the biochemist and the Nobel Prize winner developed a theory called thermodynamical hypothesis. And what this hypothesis briefly states is, from the first assembled string-like structure of the protein, we can predict its last conformation, 3D conformation. And this allows us to solve how this protein functions. And there are a lot of proteins, millions of proteins. And he popularized the idea in his Nobel speech 1972, and he published this idea in his Nobel letter in 1972. Actually, what AlphaFold2 achieves, how accurate is it to predicting this 3D last conformation of the protein? As we can see in the figure, on the right hand side, there are past state-of-the-art models in predicting the 3D shape of the models. For example, AlphaFold1 were predicting with about 60% accuracy. However, AlphaFold2 achieved a huge leap in prediction accuracy, and it is so accurate that it competes with the experimental methods in the field with respect to accuracy. So it is so accurate. What is the benefit of this to the science, right? First of all, the most used technique to determine proteins 3D conformation today is X-ray crystallography. And this is very costly experiment, requires special training of teams and gigantic scientific tools like this building on the picture. And let me first introduce the biochemist Raymond Stephenson's report about the financial cost of this experiment. He states that in his report in 2003, the cost and value of the protein's 3D structure, he states that the cost of this experiment on average is $150,000, and this requires 1 year of careful conductance of the experiment. In contrast, AlphaFold2 can calculate the 3D conformation of the protein in just less than a week. This is how beneficial AlphaFold2 is. And the other benefit of AlphaFold2 in science is that it is showing the potential of the use of deep learning in science. What this means? Without deep learning and known algorithms, the calculating protein's 3D shape, determining it, would require a time more than a life of age of the known universe by far. But this deep learning model achieves this in less than a week, with slightly dropped accuracy, of course. And actually, this development becomes role models for other researchers to merge their researches with deep learning techniques like AlphaFold2. And it actually strengthens the idea of the computational science, which states that the scientific discoveries should be aided with computational techniques. And I just touched 2 benefits of AlphaFold2 in science today, but it is more than that. For example, the 80% of the proteins, diseases caused by the proteins, and if we understand how proteins malfunction in these diseases, we can solve a lot of the diseases. Thank you for listening me, and maybe one day in the future we will completely merge the science with the deep learning tools. And thank you for listening me. Here are my references. If you have any questions about it, it would be great to answer them.